we choose the inductor current and the capacitor voltage as our states, okay, because that would make life much easier for us, because we know that if we have IL, we can find its voltage by taking derivative, and if we have VC, we can find the current by taking the derivative. So that's what we have. So in this case, we know that like we have one state which is IL, another state which is VC. At the same time, our output is the same as VC in this case, right? So, and our input, like our U, is the duty cycle. Okay. Now, so we have to come up with the transfer function. So the first step is to do things in the time domain and then take the Laplace transform to find the transfer function. Okay, so let's look at this voltage. Okay, first of all, if this switch is on, right, our circuit, it's gonna switches on, our circuit is gonna look like this. Switches off, our circuit, it's gonna look like this, right? The diode is conducting in this case. In this case, diode is open, reverse biased. The switch is open, so we're disconnected from the input voltage. So this is what we have, right? So for this much time, the duty cycle times the period, we are in this state, and for this much time, we are in this state, or in this mode and this mode. Okay, so in this case, let me just write down the voltage of the inductor. VL is equal to L dIL by dt. It's equal to Vin minus Vc, right? Is that okay? This is Vin, this is Vc, right? VL is equal to Vin minus Vc. So I can write down that dIL over dt is equal to 1 over L Vin minus Vc when we are in this state. Okay, this is constant, this is constant, this is what we have, right? This is what we have. Okay, in this part, VL, which is this case, and this is VC, VL is equal to negative VC, right? So it means that, and let me just write down VL, which is equal to L dIL by dt, it's equal to negative VC. So it means that dIL by dt is equal to negative VC over L. Okay, so let me actually write this one here. Okay, so this is one equation that we have for IL. Let's do the same thing for the current here. Okay, so at this point, IC is equal to IL minus IR, right? I'm writing KCL here. This is IL going to IC. IL is going to be IC plus IR. So IC it's going to be equal to IL minus RR. So IC is equal to C dVC over dt. IL is one of our parameters, one of our states, so I'm going to keep it like this. IR, I'm just going to write it as VC over R. Okay, so now this was DIL or DT. Now we know that dVC over dt, it's going to be 1 over CIL minus VC over RC. I just divided both sides by C. So this is what we have. So for this much time, this is DIL over dt and this is dVC over dt. Let's do the same thing here. But if you look at it, it's going to be exactly the same thing in this case, right? We have like IL is equal to IC plus IR. So it's exactly the same equation in this case. dVC over dt is equal to 1C 1 over CIL minus VC over R. Okay. Now I want to find the transfer function of this system, right? Now I have two different systems here, right? Like how can I find the transfer function? How can I merge these two? So I have to find the average. Okay, I have to find the average of this value and the average of this value. Okay, to give you an insight over this, if I draw DIL over dt, this is like a little bit simplified, but for this period it might be this much, right? For this period it might be this much, or actually it's negative, right? So it's gonna be this much. Okay, so how can I find the average value of DIL dt? If this was just like a function f, how do you find the average? It would be this thing multiplied by dt plus this thing multiplied by 1 minus dt, right? So we're going to do exactly the same thing, right? We want to find the average value of, so from this point on, now that we have the equation, we don't need the circuit anymore, right? We needed the circuit to derive the equation. Now, so I want to find the average value of DIL dt. So it's going to be d times t multiplied by 1 over L V in minus Vc plus 1 minus dt times negative Vc over L. So I make this one negative Vc. Okay, but you remember that this is the area. The average is the area divided by the period. So if we divide this by the period, this is going to be gone, right? So this is the average value of DIL over dt. So this is done. We don't need this anymore. We do the same thing here.